Hello, I'm Selvas-Sala. In this work, we introduce SALMUBench, a benchmark for sensitive association-level multimodal unlearning in clip-like models. Clip-like models are widely used as embedding backbones, but their training data often comes from large web corpora. If sensitive information appears in that data, the model can learn associations between a visual identity and private attributes, such as a phone number or an email address. This motivates selective removal of learned sensitive information. Here, successful unlearning should be precise. The goal is not to erase the person from the model or to damage the model more generally. We want to remove the requested persona PII association while preserving identity information, unrelated facts, and utility. SALMUBench has three main contributions. First, a synthetic dataset of face PII associations. Second, a clean and compromised clip reference model trained from scratch. Third, a structured evaluation protocol that measures both deletion and collateral damage. The full pipeline has 4 stages. Initially, we construct the SALMU dataset with sensitive associations. Then, we pre-train 2 reference models, clean and compromised. Next, we apply unlearning methods starting from the compromised model. Finally, we evaluate the resulting model against the 2 references. We explain each stage in more detail in the following slides. Dataset construction starts from synthetic face anchors. For each identity, we generate identity-preserving images, filter and curate them, assign fictitious PII attributes, and paraphrase captions with an LLM. The output contains 774 fictitious personas, about 60,000 image-text pairs, and 7 types of sensitive attributes. Here, we show an example of a persona in the dataset. On the left side, we have a reference image and fictitious personal data. On the right side, we have generated images and paraphrased captions linking the identity to private attributes. These paraphrases make the target a semantic association, not a fixed text template. The benchmark is organized into a retained set and a sensitive set. The retained set contains non-sensitive image text data and is used to train the reference models and support utility evaluation. The sensitive set is fully synthetic and contains the face PII associations injected only into the compromised model. The sensitive set is partitioned into forget and holdout subsets. The forget subset is the only sensitive data shown during unlearning. It combines association-level deletion, where selected facts are removed, and identity-level deletion, where all facts about selected personas are removed. The holdout subsets are evaluation only and measure collateral damage at the association and identity levels. To isolate unlearning effects, we train 2 ViTV16 clip models from scratch. The clean reference is trained only on the retained set. The compromised reference is trained on retained plus sensitive data, and all unlearning methods start from it. The goal is to match clean on forgetting metrics and preserve compromised on utility impact metrics. SALMUBench evaluates models with 10 metrics. Forgetting efficacy metrics are computed on the forget set and use clean as the target. Utility impact metrics use compromise as the target and include general knowledge, holdout-based collateral damage, and retained synthetic knowledge. We also standardize the unlearning budget for a fair comparison across methods. Here we show the main results table at a 5 times budget. The important point here is that methods must be evaluated across all metrics, rather than by a single forgetting or utility score. This multi-metric evaluation reveals 3 failure modes among the evaluated baseline methods. Some methods are catastrophically damaging. They erase the target but damage general capability. Some other methods overgeneralize. They reduce sensitive information leakage but erase broader associations, including holdouts. Other methods are ineffective. They preserve the model better but fail to fully erase the requested association. The main conclusion is that standard forget-retain evaluation is insufficient. SALMUBench exposes hidden collateral damage by testing both deletion and preservation across multiple dimensions. We release the code, dataset, models, evaluation tools, and leaderboard through the project page, which can be accessed via the QR code. If you are attending CVPR, feel free to visit us during poster session 6 on Sunday, June 7th at 3:30 p.m.